Good afternoon and welcome everybody to Homework Helper 1.10, which I guess would round to 1.1, but for the sake of argument we'll call it 1.10. Today what we're going to be looking at in our Ready section is we're going to be looking at arithmetic and geometric sequences. We're going to be comparing the two and kind of seeing how those differences evolve when given similar numbers. For example, when we look here at number 1, we're given an arithmetic sequence where f of 1 is 2 and the common difference is 3. And then here we're given a geometric sequence where g of 1 is 2 but the common ratio is 3. So all things are kind of the same. Our n sub 1s are identical, and in this case our rate of change, our common difference, or our common ratio is going to be the same as well. So we're just going to explain and look at what's going on here. So f of 1, that's telling me I'm doing the arithmetic, is going to be 2. And then I know I'm adding 3 each time, so 2 plus 3 is 5. 5 plus 3 is 8. 8 plus 3 is 11. And then 11 plus 3 is, whoops, make a little equal sign there, is 14. Okay, that one's pretty easy enough. Let me zoom in a little bit so we can see this just a little bit bigger. And let's get a little focus. And then for the geometric, we're going to be doing the same thing. We're going to be building that recursively, but this time we're going to be multiplying because it's a ratio. So g of 1, of course, is still 2. And now my ratio is 3, so that means I'm multiplying by 3, which is going to give me 6. And so that's going to be 6 times 3, which is going to be 18. And that's going to be 18 times 3. Oh boy, I don't know that off the top of my head. 18 times 3? It's going to be 54. And then I've got to do 54 times 3, which I believe is 162. But let me make sure I am right. 54 times 3. All right, look at me being smart. And so what we can see here when we compare these two results is just how drastically different these numbers are. I mean, like 2 and 2 are, of course, the exact same thing. 5 and 6, well, 6 is just slightly bigger than 5. But 8 and 18, well, now it's a 10 difference. 11 and 54, it's like a 40-something difference. 43, and then 14 to 162. We see how very, very quickly that these things are getting away from each other. So when we think about it, which value do you think will be more, f of 100 or g of 100? Do we think the arithmetic sequence is going to be higher, or do we think the geometric sequence is going to be higher? I mean, clearly I think it's going to be the geometric. And why? Because it grows, I should say, not just goes, but grows faster and larger. Right? We can see that g of 5 is already way ahead of f of 5. And that's true of everything except for our first term, except for f of 1 and g of 1, which were the same. But all the others, we could see that g was much, much higher than the others. And in fact, by the time we get to 100, it's probably going to be incredibly so. Okay, so that's what you're going to be doing for this section. Let's go ahead and zoom out a little bit, turn the page. And so here, we're being asked to find missing terms in geometric sequences. And this is similar to what we did today in class. When we're looking at geometric sequences, again, there's a couple different ways to look at it. Now, geometric is very different than arithmetic. That change isn't the same thing as slope, so it's not slope. Okay, so don't make that mistake. Geometric means we're doing something a little bit different. And so let's actually look at what's going on here to find these geometric sequences. So I know that I'm going to be taking 3, multiplying it by a number, multiplying it by a number to get 12. We'll call that our common ratio. And now I'm just going to write it as r, just to keep our lives a little bit simpler. But it would be the same thing as common ratio, CR. So I know 3 times r equals 12. So I know that 3r squared equals 12. So if I divide by 3, I know that, I'm just going to move it over here, r squared equals 12 divided by 3 is 4. So now I have to square root both sides. and r equals the square root of 4, so what number times itself is 4, and I know that that is 2. And in fact, it's not only 2, it could be or negative 2. I'd be happy if you just saw that it was 2, but I'm going to throw that negative 2 in there for a reason, because look at what happens. If I had r and I multiplied it by 2, I would get 6. If I multiplied 6 by 2, I would get 12, so I know that that's correct. But what if I multiplied it by negative 2? 3 times a negative 2 would be negative 6, and then negative 6 times 12 times negative 2 would be a positive 12. So actually both numbers work, because remember, while 2 times 2 equals 4, negative 2 times negative 2 will also equal 4. So we actually end up in a weird situation where we have two answers because we took the square root of a number. Again, I'm very focused on making sure you guys are seeing that 2 is the right answer, but for those of you that really want to persevere and seek more, who are really pushing yourselves to do higher level math, I want you guys to be able to see that negative 2 is here. Oops, I really had this off the screen. But yeah, here we had 2 times 2 is 4, and negative 2 times negative 2 is 4. So here there's actually two answers. It could be 6 or negative 6, so we say plus or minus 6. Next, we're going back to determining explicit equations of geometric. And this is kind of nice. It gives us the f of 1 is 8, and it tells us the common ratio is 2. And we know from so many previous Post-it notes, here, let me just find one real fast, because I know I have it. It's probably right here from yesterday. Oh, there it is. We know from so many previous Post-it notes how to find the explicit function of a geometric sequence. And I know all I need to do is take f of x, my n sub 1. Well, this is my n sub 1 right here, right? This is when x is 1, so that's going to equal 8. That's my n sub 1. I multiply that by my common ratio, which is, I'm told, is 2, and I put it to the x minus 1 power. And I am done. That's it. Pretty easy. All I have to do is follow the formula, make that top ramen, follow the directions. Cup noodle, I think, was the example we used in class. But I do actually want to go to a different one here. I want to look at number 13 because I'm feeling this is going to stump you guys a little bit. But let's actually look at what's going on here. So in this case, we're told f of 1. So, okay, that's great. So I know f of x is going to equal 5/3 times my common ratio. But what's my common ratio? Well, it doesn't tell me what my common ratio is. Instead, what it does is it gives me the recursive. And how can I find the common ratio in the recursive? Well, all I have to do is, again, look here, and I see that the common ratio is the number I'm multiplying by f of x minus 1. And there's the number I'm multiplying by f of x minus 1, so I know that's my common ratio. So it's just going to be times 4 to the x minus 1 power, and I'm done. So we have to use the information from this recursive function to realize what our common ratio is and apply it accordingly. Here's our n sub 1. And there we go. Okay, that's going to be it for today, folks. Is that it? That's it. Great. No secret pages. Do the best you can on this. Keep working on it. Recognize the differences between geometric and arithmetic. That's going to be the key to doing well in this section. And is just read the directions. Make sure you know if they're telling us to do geometric or not. Because again, on the quiz, that's the thing that kind of bites us. So pay attention to that. Have a good day, and I will see you tomorrow.